Hello everyone, this is Manikanta from Pragati Engineering College, Surampalam, Andhra Pradesh, studying final year ACE. This video is about what I have learned during the internship provided by Emertxe. In this internship, I have completed a project, home automation using Arduino in Pixim Lab and Blink IOT app. These are the topics which I want to discuss in this video, and these are the topics which I have learned during this internship. First of all, introduction to home automation. That is, what is an IoT, what is home automation, and what are the advantages of this, and the requirements for this project, and C programming, which is used to write a code for this project, Arduino module, which is used in this project, and what are the different peripherals that is required for this project, and what are the different software which I have used in this project, that is Pixim Lab, Arduino IDE, and all emulator, and Blink app, which is used to control the devices in our house using our smartphone. And finally, project implementation. We see the project implementation at last. First of all, see the concepts one by one. Home automation using IoT. First of all, what is a home automation? Home automation is nothing but in controlling the devices which we have in our house using our smartphone. That is nothing but in home automation. In this home automation, we can control the devices in our house using our smartphone from remotely. Nowadays, we are seeing in our house we have a lot of devices. That is nothing but in refrigerator, air conditioner, laptops, computers, and other devices. The number of devices are increasing by day. For this, we need to controlling all these devices is difficult to us, and for this we use this home automation. In this, we need to connect all the devices to a network, and that network is connected to an internet. By using this internet connection, we can control the devices easily and remotely. By using this home automation, we can automate the things which I have done manually. That is nothing but switching on or switching off of a fan or light. We can automate these things. In this project, by automating three things, that is garden lights control, temperature control system, and water tank control system. We see one by one. And the project requirements. For this project, you should have a knowledge on embedded C and C++, which is used to write a code for this project, and using Arduino IDE software. Arduino IDE software is used to convert a code that is written in C or C++ into an hexa file. We know that the code which we have written in C or C++ that is cannot executable in any Arduino board or any other hardware. Every hardware device requires only a binary code which is in a machine language. For that purpose, we need to convert the code which you have written in C or C++ into a hexa file or binary format. For that purpose, we require this Arduino IDE software, and we require a Pixim Lab software. I done this project in a software, not in hardware. For that purpose, we don't need to buy any hardware devices. We can simply install this Pixim Lab software. We can complete this project virtually. For that purpose, we require this Pixim Lab software, and now we use a null emulator software, which is used for similar serial communication between Arduino IDE and Pixim Lab and serial tank. Sorry. 16:2 CLCD display, which is used to display the temperature and the water level on the display. LM35 temperature sensor and LDR sensor, which is used to automate the garden lights, and we also require pulse width modulator. And finally, we need to configure the Blink app to control the devices by using our smartphone. The main elements of this project is light control, temperature control, and water level control. This is the main prototype or mapping of this project. This is our house. In our house, we have a lot of devices like mobile, telephone, light, fan, and other devices. We need to control all the devices using this mobile app. For that purpose, we need to install a Blink IoT mobile app in our mobile. That Blink IoT mobile app is connected to a Blink cloud server using internet. Whenever we turn on or turn off any device in our smartphone, that sends a signal to this Blink cloud server using internet. Then the cloud server sends the signal to this Arduino board. Arduino board processes those signals and sends those signals to the devices which we have in our house, and then the devices in our house turns on or turns off based on our controlling. This is the main mapping or prototype of this project. We require C programming for embedded system because we have some specific reasons. In C programming is in processor independent. It does not depend upon any processor to run. So C programming is used in embedded systems, and C programming is a portable language which we can easily use. C programming is high performance, and we can easily manipulate. Bit manipulation is easy in C programming, and we have a good memory management in C language. In this internship, I have learned some of those concepts in C language. That is nothing but data types, conditional constructs, operators, arrays, pointers, functions, recursion, string, storage class, and preprocessors. These are the concepts which I have learned during this internship, and I use some of those concepts in this project, and I have also learned some of the concepts in C++ in this project. The Arduino module, which is a very popular board which we used in a lot of projects. This Arduino Uno board has a 8-bit processor, that is Emertxe 328P, and this Arduino board contains other devices like crystal oscillator, serial communicator, and voltage regulator, which is used to process the signals which is sent to this Arduino board. This Arduino board cannot run the file directly that is written in C or C++. For that purpose, we need to require this Arduino IDE software. This Arduino IDE software, C and C++ languages. This Arduino IDE converts the code which I have written in C and C++ into an hexa file that is executable by this Arduino board. For that purpose, we require some of the libraries. Those libraries are installed in this Arduino IDE software. Based upon our uses and our project, we need to install these libraries in our software Arduino IDE. So this is the view of this Arduino IDE software. Let us see the view of Arduino IDE software. This is the Arduino IDE software view. In this we have different options, file creation and other options, and we need to compile the code, and this option is to convert the code into a binary language code. And in this tools option, we can install the libraries based upon our requirements. In this we can install libraries. This is the code which I have written for this project. And then PiximLab software. This PiximLab software is a real-time emulator for developing the boards. This PiximLab software, we have a different types of boards. In this PiximLab, we can select Arduino board and other boards based upon our requirements. We can perform any project in software by using this PiximLab. This is the view of this PiximLab software. Let us see this PiximLab software. This is the PiximLab software. In this PiximLab software, we can select any board based upon our requirement, Arduino Uno or breadboard or any other boards based upon our requirement. And this is a microcontroller. We can select the microcontroller based upon our requirements. In the module, we have an option like the spare parts. These spare parts are nothing but peripherals which we required for any project. In these spare parts, we can select any input device like switches, keypads, LEDs and others. We can also select the output based upon our project requirements like LCDs, LEDs and other. And we can select other IO devices also. These are, we can select any input or output devices based upon our requirement. And the peripherals required for this project are LDR sensor and LEDs, which is used for the garden light automation. This LDR sense based upon the light intensity on this LDR sensor. When we place an LED on this LDR sensor, then the resistance increases and the lights turn off. This used for nighttime and daytime lighting. When we turn on a light on this garden lights, then automatically the garden lights turns off. That means whenever night time only the lights turn on and morning time lights turn off automatically based upon the light intensity. And the temperature system consists of an heater, cooler and LM35 temperature sensors. You can explain each one. And serial tank. This serial tank is used to read the volume of the water tank through serial communication. These are some of the screenshots of this project. Let us simulate the project real time. And opening the PiximLab software. This is the PiximLab software. In this PiximLab software, we selected an Arduino board, and this Arduino board have a processor Emertxe 328P microcontroller. I load the hexa file into this by using this option, and I selected the peripherals. This is nothing but an Ethernet board that is used for this communication, and this is a temperature system. In this temperature system, we have a cooler and a heater which are connected to the ports of this Arduino board. And this is the CLCD display which is used to display the temperature and volume of the water tank, and the water switches are turn on or turn off. For that purpose we use this. 1 minute, I am connecting my mobile screen to this. I connected my mobile screen to this laptop. In my mobile, I have installed a Blink IoT app. Opening Blink IoT app. In this Blink IoT app, I have two tabs, tab 1 and tab 2. This tab 1 is used to control the temperature system, and tab 2 is used to control this water tank. In tab 1, I have turn on this cooler, then automatically this cooler turns on. Whenever I turn on this heater, then this temperature starts increasing. You see, this tab 2 is used for water tank controlling. I selected a serial water tank. This is a serial water tank, and this serial water tank has a capacity of 3000 liters. Whenever I turn on an inlet valve, then this water starts rising, and whenever it reaches the 3000 liters, then automatically inlet valve stops whenever the water tank fills. Now I turning off on the outlet valve. Whenever I turn on this outlet valve, then the water level starts decreasing. Whenever this water level reaches a certain level, then automatically the inlet valve starts automatically. You see, automatically the inlet valve turns on whenever it reaches a certain level. By using this, we cannot waste the water, and we can also monitor the water level of this water tank in our mobile app. It shows this water level. And we can also see this water level on this display also. see this temperature system. This temperature system, now I turn on the heater, it reaches the 38.61 degrees. Then automatically whenever it reaches a certain temperature, it stops the heater. Now we say it reaches a 40 degrees, then automatically heater turns off. Now I turning on this cooler, the cooler turns on and then temperature starts decreasing. Whenever the temperature reaches a certain level, then automatically this cooler switch is on. By this way we can automate this water tank and temperature system. By using this we can automate these things. These are some of the other screenshots of this project simulation. Finally, concluding this video, in this internship I have learned about IoT home automation and scope of IoT in future, and I also learned how to use the data sheets of any peripheral. In any project we require a lot of peripherals, but we don't know how to use any peripheral or what are the pins. And in this internship I use the data sheets of every peripheral and learn a lot about these data sheets and peripherals. And I also learn about how to configure an Arduino module in Arduino IDE software and how to use these different softwares. Thank you Emertxe for giving this opportunity to me, and thank you all for watching this video.